Okay. So what we're talking about in this lesson is we're continuing with sample distributions, but now we're going to focus on a mean. And so the sample distribution of a mean is when you have quantitative variables. And the formula for mean is that they're going to give you the mean, and the standard deviation is just the standard deviation they give you over the square root of n. And remember, n represents the number of people in the sample or the number of items in the sample. Now, when you talk about the mean and the standard deviation, the name of it you say is y bar, or the standard deviation of y bar. You can also say sigma y bar, but that lets you know that you're talking about specifically for the sample you're dealing with, not all samples. So yesterday we had some conditions, and so we have almost the same ones today. The first condition is the same. Is it independent? If it's not independent, you can either assume independence or check that it's less than 10% of the population. The next thing you need to know is if is it random. And the last one's, is it large enough? If it's skewed, it needs to be a pretty large sample to take care of the skewness. If it's not skewed, then it won't matter, okay? But if you have a large enough sample, remember our activity, when we found at least 100, taking, I think when we got up to 30 samples or more, things became less skewed, so it works out. So it kind of depends on the problem, on whether or not it's large enough. And as we get to more examples, we'll be able to talk about that more. Okay, so let's go ahead and start off by looking at this one. So why don't you go ahead and copy this down. And if you notice, it's talking about means. So I'm going to write down the mean and the standard deviation it gives me. Okay. And so the mean that it gives me is 500, and the standard deviation it gives me is 100. Now it's asking for, what about the mean of a random sample of 20? So now I have a sample of 20. My mean now becomes y bar. This is the mean. But it's still 500. It's my standard deviation that's going to change, because the larger the sample, the smaller the standard deviation you're going to get. And so my sample standard deviation is going to be the standard deviation you have over the square root of n. So it's the given standard deviation over the square root of 20. And so when you plug that in the calculator, you get 22.36. So this is the mean and the standard deviation when you have a sample size of 20. The conditions that we were supposed to check is if they're independent, less than 10%, random, and large enough. Okay, so we're going to say that it's independent, and it usually is independent because people's test scores are independent of each other. The only time it might not be independent of each other is if maybe we've taken 20 scores from one particular college. And so kids had to have a certain score to get into that college. So that might be an example. Yes, we can say that 20 students is less than 10% of population. And it's a random sample of 20 kids. And then if it's large enough, this is when we have to know if it looks normal, but it told you here that it looks normal. So 20 is large enough because it is normal. If it was normal and it was skewed, 20 might not have been large enough to make this work. So those are the conditions you would have to check. Now, since I checked those conditions, I'm done checking those conditions for this problem. Okay, so let's look at the next one. What scores would be considered abnormally high? Well, for a sample size of 20, my mean's 500, and abnormally high, I would say is 2 to 3 standard deviations above. So you can actually just add this 22.36, which is 544.72, right, for the second one. I would say anything above 544 is high. And it's high because it's 2 standard deviations above. What percent would score above 550? Okay. Well, again, this is all based on our sample of 20 students. So 500's here, 550's here. I know it's going to be a small percent because it's past the second standard deviation, but I'm going to do my normal CDF. So second distribution, normal CDF. My lower point is 550. My mean is 500. Oh, my upper point, sorry. My upper, I'm just going to pick a big number. You can pick 800 because 800 is the highest SAT, and that's pretty far from our mean of 500, so it should work out okay. And then our standard deviation is 22.36. And so 0.0127% of the time will someone get that high. So only 1.3% of the time will someone score above 550 on a population of 20 students. Not a population, but a sample size of 20 students. All right, let's look at the next one. What score would represent the 90th percentile? So I still have my mean. And 90th percentiles up here. But this time what I'm going to do is I'm going to do my inverse norm. And so inverse norm, my percentile is 90%, my mean is 500, and my standard deviation is still the same for that population or that sample. And so a cutoff of 528.7 is going to be the top 90th percentile. So when you're doing both sets of these problems, the big thing you have to do is you have to recognize if it's a proportion or if it's a mean. If you're dealing with a proportion, you'll use this standard deviation. If you're dealing with means, then you'll use the other standard deviation. Remember to check and explain your conditions before you do your work, and then you just follow the processes.